So water is leaking from a hole at the bottom of a large tank. The volume of water in the tank is V, yeah, time t. Now the rate of decrease of V is directly proportional to V cubed. So of course V is going to decrease, isn't it? Because there's this hole there, so the volume's going to go down, right? So if V was a curve, it would sort of go down like that, wouldn't it? It'd have a negative gradient. Okay, hence the fact that it's decreasing. All right. So the rate of decrease, we're interested then in dv by dt. Okay, how v is decreasing with respect to time. Okay, and that would be proportional to well, decrease. Then of course you need to have that minus there, yeah, because the word decrease. Got to important you have that minus there. Shows negative gradient. It says v cubed. Yeah. So to answer part A, then of course we can write this as a differential equation if we put an equals there and put a k in there to have this constant of proportionality. So as part A answered you 1 mark. So this is given that v is 60 when t is 0, show this here. So what I'll do then, right, is of course I'll separate the variables, right, for part B to integrate to get v equals, or in this case v squared. So separating the variables. So we get the v's onto one side, so dv by v cubed in this case will equal to the minus the integral then of k dt. Okay, so v cubed's on the bottom, so I need to take that up before I integrate. Okay, and I've got the minus integral of k dt. So when I integrate this, add 1 power to that, so it'll be minus 2, divide by the new power. That will equal to minus kt plus c. Okay, so I can sort of better write this by putting that down. Okay, there's a minus there, of course, minus in front there, so put it in the front of the whole fraction. Bring that down to be v squared. There'll just be 1 left on the top, and there's a 2 there, isn't there? So 2v squared equals to minus kt plus c. And then if we put these conditions in, like when v is 60, t is 0, yeah? When t is 0, v is 60. So just substitute that in. So we've got minus 1 over 2, what is it, 60 squared, okay, equals to t is 0. So that will just go, won't it? You know, you'd have minus k times 0 plus c. So that implies then c will be that, whatever that is, right? So just checking my calculator what it is. 1 over 2 times 60 squared. Okay, and I got 1 over 7,200. Okay, so that's what c is. It's minus as well, of course. Let me not forget, because it's c and then equals to minus of all of that. So put it in. I've got minus 1 over 2v squared equals to minus kt minus 1 over 7,200. Okay, so there's a few things you can do here. Now, first of all, of course, because they're all minuses, I'll just change the signs. So I can say, look, 1 over 2v squared is kt plus 1 over 7,200. Perhaps what I'll do, just like in the previous question, I want to put these two together. It'll be sensible to write this as a single fraction, alright? So if I scale this up, so it's a fraction, of course I can write that as 7,200 kt over 7,200, okay, just by scaling it up. So I've got a denominator of 7,200. Of course, when you divide, that's just 1, so I'm not doing anything wrong. Okay, and because the fractions then are the same denominators, I can put them together. So I get 7,200 kt plus 1 over 7,200. Okay, and then I can use this then to get my v squared almost. So what I can do, because I got single fractions both sides, I can flip this. So I can say, look, that's the same as 2v squared over 1, yeah? I don't need to write over 1, but I'm just flipping that fraction. But of course, if I flip this side, I need to flip this side as well. So it'll be 7,200 over 7,200 kt plus 1. Okay, so yeah, that's what I've done. If we want to be clear on that, I've just flipped that fraction there. So 2v squared over 1, and then flipped this here. So I can say they're equal. So looking at what I need to get is this format here. So now I've got this 2 in front, so if I take that 2 over and divide, okay, so, or divide both sides by 2, I can sort of think of it like that. So if I divide this by 2, I just get v squared, yeah? If I divide this by 2, well, you divide the top by 2, so you get 3,600, okay, over that. And it's effectively what we've got here, yeah? Except they've got this a here. So what we can say is, look, that becomes a, yeah? Because it's a constant, so we can say, look, let 7,200k equals to a. Okay, we're allowed to do that, where a is a constant. We're allowed to do that because k is a constant, so 7,200k will be 7,200 times k, which is also a constant, and we just call it a, alright? It's a constant, so we can just change it. So we say, therefore, v squared equals to 3,600 over a t plus 1. Okay, part C then, it says, when t is 2, the volume of the water in the tank is 50. Okay, so when t is equal to 2, v is equal to 50. So we can sub that in. So we say, look, 50 squared equals to 3,600 over a times 2, so 2a plus 1. So what I can do then is swap these around. So 2a plus 1 is 3,600 over 50 squared. And then, of course, I can just get a then from here. So I can say 2a is equal to 3,600 divided by 50 squared minus 1. And then, of course, to get a, I just need to divide this answer by 2. So let's work that out. 3,600 over 50 squared, take away 1, and then divide that by 2. So I get my answer to be 11 over 50. Okay, so I can say, therefore, v squared is 3,600, 11 over 50t plus 1. Okay, so that's my expression for v squared. And what's it actually asking for then? Find the value of t when the volume of the tank, volume of the water in the tank is 27. Okay, so we can put 27 in there. Swap these around. Okay, so I'll do it up here. Okay, so then 11 50th t equals 3,600, divide by 27 squared, take away 1. Okay, so if I do that on my calculator, okay, so I get 11 50th t equals 319 over 81. To get t then, take the 50 up and divide by 11. So times my answer on my calculator by 50, divide that answer by 11, and I get 17.9, correct to 1 decimal place.